Today we're going to start our unit on inequalities. An inequality is a statement that two quantities or expressions are not equal to one another. So that means when we solve an inequality that we're finding a range of solutions that satisfy the statement. So that means we're finding a range of answers that will make the statement true. Because I'm not here today, we will go over the rest of this page in class on Monday. So let's go ahead and skip to the next page. Alright, this page is starting linear inequalities. So go ahead and write that at the top of your page, linear inequalities. So with linear inequalities, just like a linear equation, your degree is an understood 1. Okay, so for linear, my degree is an understood 1. Well, how are we going to solve these inequalities? We're actually going to use the same methods that we use to solve linear equations. So that means all we're going to do is we're going to isolate x. So we're trying to get x by itself. So while we're isolating x, the only major difference with solving linear inequalities is that we have this property right here that says if we're dividing or multiplying by a negative number, then you need to flip the inequality sign. So make sure it's only when you're dividing or multiplying by a negative number that we do this. All right, let's take a closer look at example number 1. Alright, example number 1 gives us negative 3x plus 4 is less than 11. So we want to try to get x by itself. So that means the first thing I'm going to do is subtract 4 from both sides. So I get negative 3x is less than 7. Then divide by negative 3. If I divide by a negative, I have to flip the sign and I get negative 7/3. So my answer would be x is greater than negative 7/3. Let's take a look at example number 2. So it's another linear inequality, so I'm going to try to isolate x. So I'm going to subtract 2x from both sides and also add the 3 over. So I'm going to get 2x is less than 8. Then I simply divide by 2. Since I'm dividing by a positive number, I don't have to do anything, so my answer is x is less than 4. Now these first two examples, let me erase that. The first two examples were examples of what we call one-sided inequalities. If we look at the next two examples, number 3 and 4, notice how we have a two-sided inequality. So to solve a two-sided inequality, you're just going to try to get x by itself in the middle. So the first thing I'm going to do is add 4. So if I add 4 to the negative 6, I also have to add 4 to the 2. So I'm going to get negative 2 is less than 2x, which is less than 6. Now I'm just going to take everything and divide by 2. So I'm going to get negative 1 is less than x, which is less than 3. Very simple. Alright, let's do one more linear equation. So let's go over to number 4. This time I have a fraction, so I want to get rid of that fraction. So I need to go ahead and multiply both sides by 2. So I'm going to get negative 10 is less than or equal to 4 minus 3x, which is less than 2. Now I'm going to subtract 4 from both sides. So I get negative 14 is less than or equal to negative 3, which is less than negative 2. Now I'm going to divide everything by negative 3. And when I do that, I have to flip both signs. So it's going to become a positive 14 over 3. I flip the sign. It comes a positive 2/3, I flip the sign. So my answer is 14/3 is greater than or equal to x, which is greater than or equal to 2/3. Now notice right now we're leaving our answers as inequality notation. Like I said, we're going to go over how we would write these answers in interval notation on Monday. All right, our last type of inequality that we're going to discuss today is an inequality that contains an absolute value. All right, so just like an absolute value equation, we have to compare this absolute value to a positive and a negative value. So there's two properties of absolute value inequalities that we're going to have to know. The first property says if the absolute value of x is less than b, then what we're going to do is we're going to rewrite the problem as negative b is less than x, which is less than positive b. So this is what we call an AND statement. So notice it depends on the inequality sign. So this is if the absolute value is less than b. Our second property says if the absolute value of x is greater than b, then this is how we're going to rewrite it. Then you're going to rewrite it as the x is greater than b, or x, if I make the b negative, I flip the sign. This is what we call an OR statement. So this is what we call an OR statement. So again, what you're looking at is the sign. See how the absolute value is less than b. So it's an AND statement. If it's greater than b, it's an OR statement. So like I just said, this is how I tell the difference between whether or not forming an AND or an OR. And it's worked for me for years. If it's less than, then it's going to be an AND statement. If it's greater, it's going to be an OR statement. And remember, this is only if we have an absolute value. Now notice for the OR statement, we're going to have two intervals in our answer. And when we rewrite our answer in interval notation, we're eventually going to use this symbol called the union symbol. So this stands for the union. It's going to take the place of OR. But again, we're not going to get into that today. We're just going to do the basic part of solving it, and then we'll talk about on Monday how to rewrite our answers. So let's take a look at my first example here. I have the absolute value of x minus 3 is less than 5. So just like with an absolute value equation, you want to make sure the absolute value is by itself. So in this case, the absolute value is by itself. So then I'm going to say, okay, what is it telling me? It says the absolute value is less than 5. So less than is an AND statement. So that means all you're going to do is remove the absolute value. So I get x minus 3 is less than 5. And then on the left side, you're just going to put negative 5. Well, my inequality signs always have to be facing the same direction, so it's also going to be a less than sign. Now notice it's a normal linear inequality. So I want to isolate x, so I add 3 to both sides. So I get my answer, x is between negative 2 and positive 8. Now let's look at two more examples. So let's look at number 2 first. This time, notice my absolute value is already by itself. So I look at the sign. It says greater 9. So it's greater than 9. So if it's greater, it's going to be an OR statement. So to form my OR statement, I'm going to remove the absolute value. Nothing changes. Or if I remove the absolute value, if I make that 9 negative, I need to flip the sign, so it will become a less than sign. Now you're going to solve both of these inequalities individually. So I'm going to subtract 3, I get 6, divide by 2, so I get x is greater than 3. Or I solve the second one, I subtract 3, I get negative 12. divide by 2, I get negative 6. So my answer is going to be x is greater than 3 or x is going to be less than negative 6. So again, we'll eventually get into how we're going to rewrite that answer. But for right now, let's just leave it like that. All right, this last example, now I know your note sheet looks a little different. Just kind of cross through that statement that I had under the 2 examples and go ahead and add this problem in. So we have 5 minus 2 times the absolute value of 2x plus 3 is less than 15. So notice in this example, my absolute value is not by itself. So I need to get it by itself. So the first thing I'm going to do is I'm going to subtract 5. So I get less than 10. And then I'm going to divide by negative 2. Well, if I divide by a negative, I have to flip the sign. So I get greater than negative 5. Now let's stop here for a second. Remember when we had the absolute value equal to a negative number, we said it was no solution. So notice right here I have a negative number. Anytime your absolute value is being compared to a negative number, you're going to ask yourself a question. And that question is, well, the absolute value is always positive. So you're going to say, is a positive number greater than negative 5? So ask yourself that question. Is a positive number greater than negative 5? Well, hopefully you're saying yes, it is greater than negative 5. So if a positive number is always going to be greater than negative 5, the opposite of no solution is going to be all real numbers. So my answer to this would be all real numbers. Now what if, let's say, I change this problem and instead of the absolute value of 2x plus 3 is greater than, let's say I change it to less than negative 5. So that's going to change our question. It's still going to say is a positive number because the absolute value is always positive. But this time it says is a positive number less than negative 5. Well, what's our answer for that? That should be no. So if it's a no, then your answer would be no solution. So to figure out whether it's all real numbers or no solution, you're just going to form a question. And you only do this when the absolute value is being compared to negative numbers. All right, I'm going to leave an assignment on Blackboard. Please do your best to complete that assignment. Realize if you have any questions, write them down and we'll go back through this on Monday if we need to.